Hello everyone. It's Monday, and what better way to start our programming week than with some Advent of Code? For those of you just joining in, Advent of Code is a series of programming challenges that runs between 1st and 25th of December. Every day we get a new challenge, and every challenge has two parts, but we can only see the second part once we've finished the first. Advent of Code is kind of like a programming competition, except, well, it's not very competitive. Most people use this as an opportunity to try something new. And for me, that's streaming, solving these problems, and also trying out Elixir Livebook. So this is Livebook. It's a web app. It runs in your it runs as a server, and then you open it in your browser. It lets you interleave text and code. And whenever you have code, it also executes the code underneath. So we've been solving Advent of Code using this. For example, here's the solution to part 1 from yesterday. There's a bunch of code, and then ultimately the solution underneath, the result of executing this. Now, Livebook also has much fancier features. So for example, you can generate a text input like this, and then you can read it somewhere. And then you can read it in your actual code. This is much nicer than having files littered around or hard coding the problem input in your source code. It also has even fancier features. For example, yesterday we had a graph problem. So here we are generating the actual graph, trying to draw out what the input looks like using mermaid charts. However, I haven't been using this quite to its fullest extent. Yesterday's problem was difficult because, well, the input looks like this, and this is kind of unreadable. Especially the full input, like this is supremely unreadable. Trying to make sense of this just by eyeballing it simply doesn't work. And this made solving yesterday's problem a chore. There was actually a nice solution, but well, I didn't see it because I couldn't tell what the properties of this input were. And going by the chatter on Mastodon, we could have seen what was going on here if we had just drawn this out nicely. So I had a look into how we can do that, and turns out Livebook has a few more interesting output capabilities. It can output raw HTML, and also grids, and also images. So, lesson from yesterday. If today's problem requires some sort of complex visualization, we're just going to try to do that. We're going to try to generate an SVG and shove it into an HTML. And if that doesn't work, we're going to try to generate an image and then display the image. This is a web browser after all, so it should be able to display SVGs and images quite nicely. And hopefully that will make understanding the problem easier. Like, look at this. Yesterday's visualization was not great. This was not helpful. Alright, so back to Advent of Code. Let's see what's in store for us today. Day 11. Cosmic Expansion. You continue following signs for hot springs and eventually come across an observatory. The elf within turns out to be a researcher studying cosmic expansion using a giant telescope here. Now, reminder that the whole story arc here is that we're trying to save Christmas by fixing the snow machine. You will notice that this has nothing to do with fixing the snow machine. He doesn't know anything about the missing machine parts. And also, this is not the snow machine parts. This is the sand machine parts which we need to filter the water which we need for the snow machine. He is only visiting for this research project. However, he confirms that the hot springs are the next closest area likely to have people. He'll even take you straight there once he's done with today's observation analysis. Maybe you can help him with the analysis to speed things up? The researcher has collected a bunch of data and compiled the data into a single giant image, your puzzle input. Aha, maybe we get to do some visualization. The image includes empty spaces, dots, and galaxies, hashes, for example. This is reminding me of the n-queens problem, just by looking at this. Like, clearly it's not, because we have two things on the same column, but it looks like a board for the n-queens problem. The researcher is trying to figure out the sum of the lengths of the shortest path between every pair of galaxies. However, there's a catch. The universe expanded in the time it took the light from those galaxies to reach the observatory. Due to something involving gravitational effects, only some space expands. In fact, the result is that any rows or columns that contain no galaxies should all have actually been twice as big. Any rows or columns that contain no galaxies should all actually be twice as big. So for example, this fourth row here contains no galaxies, so it should be twice as tall or twice as wide. In the above example, 3 columns and 2 rows contain no galaxies. Okay? These rows and columns need to be twice as big. The result of cosmic expansion therefore looks like this. Okay, so the third row gets twice as tall. And then this row towards the end also gets twice as tall. And then the third column, here we go. It's twice as tall it's twice as wide. Okay, so columns get twice as wide and rows get twice as tall. Equipped with this expanded universe, the shortest path between every pair of galaxies can be found. It can help to assign every galaxy a unique number. Yep. In these 9 galaxies, there are 36 pairs. Only count each pair once. Order within the pair doesn't matter. For each pair, find 36. Order 36 if there are 9 galaxies. So we have 9 times 8 divided by 2, which is 9 times 4, which is 36. There are indeed 36 pairs. For each pair, find any shortest path between the 2 galaxies using only steps that move up, down, left, or right exactly 1 dot or 1 galaxy at a time. The shortest path between 2 galaxies is allowed to pass through another galaxy. So this is the Manhattan distance. For example, here is one of the shortest paths between galaxies 5 and 9. So we have 5 and 9. This path has length 9 because it takes a minimum of 9 steps to get from galaxy 5 to galaxy 9. 8 locations marked hash plus the step on to galaxy 9 itself. Really? So it's 2, 2, 2, 2, indeed 8, and then 9. Here are some other examples, shortest path lengths between galaxy 1 and galaxy 7, 3 and 6, and 8 and 9. In this example, after expanding the universe, the sum of the shortest path between all 36 galaxies is 374. The sum of the shortest paths is 374. Expand the universe. Then find the length of the shortest path between every pair of galaxies. What is the sum of these lengths? Right? And what does the input look like? Yeah. Okay, so we're going to not solve this initially. We're instead going to try to draw it out. Because whilst we can easily display this, a small example like this, and analyze it, we can't display the full thing and analyze it, especially once we've expanded it. So, how do we do this? An interesting problem here is, okay, actually, first off, this is not a lot of input. We can absolutely just compute this manually, quadratically. It doesn't really matter. Yeah, even if we do a cubed algorithm here where we do some sort of process between every pair of stars, and then we do something that walks through every row and every column, that's still fine. This is just a small input. I also noticed that there aren't that many empty rows or empty columns. Well, there are certainly not many empty rows by the looks of it. But yeah, that's why we're going to do some visualization. We're going to try to see what this whole thing actually looks like. But what should our data model actually be? Well, we're not going to be doing stuff on the grid. Yes, we're not going to be doing stuff directly on the grid, so we're going to just be storing the coordinates of the galaxies. And then we'll also store the list of empty rows and empty columns, and then we're going to modify the coordinates by these empty rows. So for example, we'll know that this is like 4 and say 8, and since we know there's an empty row above it, it should be moved down to 5. Then everything else, this one should also be moved down 1 row, this one as well, and this one will be moved down 2 rows because there are 2 empty rows before it. Okay, so step 1, we read this input and then we extract just the coordinates of the galaxies. And also, for starters, we're just going to do the coordinates of the galaxies. And then we're going to do the list of empty rows and empty columns, then we're going to do the expansion, and then we're going to do the solution, whatever it is. There's probably some sort of raster graphics algorithm that does this sort of drawing. Actually, no, it's a Manhattan distance. This isn't going to be some complicated algorithm. At worst, it's going to have one edge case. Anyway, but first off, before all of this, we parse and then we display. Yeah, this will be good practice if nothing else. So, we are solving this in Livebook. So we start by making a new notebook. This is going to be called AoC 2023 Day 11. Probably headline here. Okay, then we save this so that we don't lose it. Some unfortunate accident. Then we're going to add Kino as a dependency, because this is what powers the input and output in Livebook. First section is going to be called helpers. Actually, first section is going to be called inputs. Then we have example 1. We only really have one example, so example, Kino input read, Kino input text area, example. This generates a little text area for us to plop our input into. We're also going to have an input for the full input. We're actually going to have a text area for the full input. Full inputs. So let's copy this in. This is our example. This is our full input. Now we can just collapse this because we won't have to look at it for a while. We're going to create a section and this is going to be called helpers. Now we can collapse this one. We're going to put stuff in helpers later. For now, we're going to make a third section and call it part 1. This is an Elixir input and it starts with Kino input read example. This gives us our example input separated as a single string with new lines in the middle. So first step is split by new lines. Okay, it's split by new lines, but we also have the trailing new line as an empty string. So we trim the input. We now have our inputs. We now have our lines one by one. Let's add an index to this list. Do I even have to say 0? I do not. Okay, so now we have our lines and the line number. Next, we're going to iterate over every line. So we take every line, then we convert it into a char list. And we add indices to this as well. Enum with index. Now we have... Actually, let's do some mapping, let's do some filtering. So first off, we filter this to only select the hashes, the galaxies. We don't care about the index at this juncture. We just care about whether ch is equal to hash mark. So these are all of our galaxies. Next up, we map this so that we have both. So we have ch and j, and then we map it into a pair of I and j, and then ch. So now this should give us the coordinates of every single galaxy. And we're actually getting one list per line. So for example, make this bigger. Here we go. The last line indeed has 2 galaxies on it, but this sort of split isn't actually helpful for us, so let's flat map it. Okay, now we have a list of coordinates and the hash. And 35 is presumably the ASCII character for hash. Let's turn this into a map. We use an enum intul for this. Okay, and now we have a map from coordinates to galaxy. How many galaxies are there here? There are 9 galaxies, as expected. Okay. Now, actually, let's move this into a parsing module in helpers. Let's call the module AoC. Let's call this read input. This takes a Kino input as an argument. And the code is this whole thing. Here it's input instead of example. Now here we can just replace all of this with AoC read input example. Does this also work on full? It does, although there are many more galaxies in full, aren't there? Map.size, length, keys, enum.length, just length. There are 434 galaxies in the full example. That's a lot. But luckily, we're going to be drawing these out. Okay, let's create a new block here. Not a block, let's create a new section here and let's call it visualization. Let's call it experiments. Because we're like mad scientists. We fork this off of helpers so that we don't keep reevaluating part 1 whilst working on this. Okay, and now I think I want to use HTML to display an arbitrary HTML, but I have no idea how this works. So let's try it out. Let's say div, let's say h1 test, and then we pipe this into Kino shorts HTML. Is this actually an h1? Yes, this is an h1, and it's... What even is this? This is an inline frame? This is an iframe. Okay, so we pass in some arbitrary HTML. It doesn't have to have a body because they do that for us. This will be in a separate iframe. Okay, how does SVG work? I want an example SVG. This should work. So let's try copy pasting this in. Let's see what happens. Well, it displayed something. Okay, so first off, width. What does this do? It creates an SVG element, then it creates a rectangle, then it creates a group with a bunch of stuff in it. So first off, I want the width to be 600. Okay, and then the height to be 400, because all the greatest displays are 600 by 400. I remember this view box thing. This describes what the actual drawing space of the SVG is. So, hold on. First off, let's remove this group. Can we comment out this group? Or we can copy paste it later. So we now just have a rectangle. Let's make it fill red. Yes. Bone-searingly red. Eye-searingly red. Okay, better. And XY. Let's have it start from 0. 0 and go all the way to the end of our display. So 600 by 400. Our view box is going to be 0, 0, 600, 400. Right. And now actually the fill should indeed be white. But the stroke should be black. Okay, so now we have a rectangle, and this is going to be our viewing, our canvas. In fact, let's make this 600 by 600, because I bet our input is actually a square. Okay. So now we have to take our input, this stuff, and then just draw it. We also need the width. So what else do we need in our input? Having just the map isn't sufficient. We also need height and the width. So here, let's say lines is this. Lines. And this should still run, yes. But this is actually now going to be called galaxies. And then we're going to return a map of several things, one of which is galaxies. If we run it, it still runs, and now it returns a map of our galaxies instead of just the galaxies. Then I want here height. Height is going to be simply length of lines. We run it here, and we have a height of 10, which is correct. Then the width is just the width of any line. It's just the length of any individual line. So we're going to do length of list.first lines. This will of course break if we have an empty list of lines, but we know that we don't have that. Oh, and it's not a length, it's not just length, it's string length. What am I doing wrong here? First argument is not a list. Oh, to actually execute it. How do I execute, cause both of them to execute? So I've introduced a compilation error here, and if I execute this, well, now it runs. I've introduced a logic error here, and it compiles, but this one hasn't errored out. But now if I do ES, EA. So EA is my shortcut for executing everything. This is string length, yep, and EA. Okay, so now we have the width and the height. So here, we now need to draw an extra rectangle for each of these galaxies. So let's just write one manually, and then we're going to write more of them later. And this actually should be black, shouldn't it? Because it's a deep space. Yes. This should be black. It should have no stroke. And then this one should be pretty close to white. Let's make it a gray. Then it has a completely white stroke. And then the width of it is what? Well, our grid is 10 by 10, so this should be width 60 and height 60. And then our x for the first one is going to be 0, and then our y is going to be 180. And this displays a galaxy sort of to the left there. Is this correct? Yes, there is a galaxy there. Right. Let's now display all of them like this. Let's do this programmatically. So, first off, we're going to say input, we're going to say data. Yeah, AoC feed input of example. Then we're going to do gal width is going to be, it's going to be 600 divided by data.width, and gal h is going to be 600 divided by data.height. So here we now have gal w, and here gal height, gal h. Okay, and then our 180 here is actually going to be 3 times gal h. And our 0 here is in fact 0 times gal w. This should still work, yes. Now we need to generate a much bigger text here. And I think we can use EEX for this, but I don't remember how to call EEX. EEX. Is this how it works? Elixir EEX. Is it a separate library? Yes. Let's go on to... This is an odd versioning scheme. Whatever, it's probably the same. So the way the EX works is you do EX eval string, and then you pass it something. And this presumably can also be a map, can't it? Oh, and we can also... Yes, we can pass it assigns, which is keyword list. But surely eval string is going to allow bindings. Get string, the supported options are described. Well, let's try it out. So EX is Elixir's inline templating engine. And we need it as a dependency first. We don't need it as a dependency first? Wait, does this actually exist? It does exist. Okay, so we type this into ex.eval string, and as an argument, we're just going to pass assigns. What do we pass? We pass galaxies, which is data.galaxies, gal w, which is gal w, and gal h, which is gal h. This should still run. Okay, and now here, instead of doing gal w, we're going to do at, which should pull it from the assigns. Not invoke at outside of a module. Fair enough, so we can't use the galaxies thing. So we can't use the assigns thing. But you can just pass a keyword list Well, string. Honestly, what I really want here is not EX, but HEX, which knows about HTML. Can I use HEX? Is that separate? Is that part of Phoenix? Components. Part of Phoenix Live View? There's no way it's just part of Phoenix Live View. Is it Phoenix HTML? Okay, let's stick to the basics then. Let's just figure out how to do this with... Yeah, let's figure out how to do this with just gal double, with just EX. Does this work? Just going to uncomment these temporarily. This does work. Okay, so we have to use this EX syntax instead of the regular Elixir syntax. Fine. Oh, and we do actually say app here. Right? Yes. And this is certainly more verbose, but it will pay off shortly. Okay. When I normally do this in Emacs, I have macros for a lot of this annoying syntax, but don't have that in Livebook. Okay, so now we have our little square drawn. Let's split this up on multiple lines so that we can read it more easily. It still works, and now we can do the thing we actually wanted to do to begin with. We can use a for. So for the galaxy is going to be gal x, gal y. I think we don't care about, and this will be coming from galaxies. Where's percent? Percent is here. Okay, and this has to end in after here. And here this we indent a bit. Instead of 0, we have gal x, and instead of the 3, we have gal y. Then this should work. Yes, we now have a drawing of our galaxy. What happens if we do this on full? We have a drawing of our galaxy. Good. Or this is a start. Shall we make these squares? We can make these squares later. Yeah, we can make this prettier later. For now, this is enough. So, next step in our little problem solving is we need to find the empty lines and the empty rows. So back to reading our input here. Finding the empty rows we could actually do by being a bit smarter about this here, because this will return an empty list whenever the row is empty. But we can do this the other way around, can't we? Because we have the coordinates of every star, and we have the height and the width, so we could just test if there is something on every line, Oh, right. So here's how we're going to do this. We're going to take just the coordinates of the galaxies. We're going to split them into two lists, the X list and the Y list. Then we're going to turn them into sets, and then subtract that set from the set of all possible X's. And that's going to be those are going to be the empty rows and the empty columns. Okay, so let's call this non-empty rows, non-empty calls is galaxies. We pipe this into map.keys. So now we have the keys. Then we pipe this into list.enum.unzip. And then we return, and then we IO inspect this to see what we actually get. We get two lists of rows, yes. Okay, next up we are going to take each of these non-empty rows and turn them into map sets. Do we even need to do that? Can we do this differently? So what happens if we do list subtraction in Elixir? What happens if we do, say, 1 through 9, or 0 through 9, then do minus minus 0 to 3? We get an argument error. Elixir list difference. Is it dash dash? And there is something here. List subtraction operator removes the first occurrence of an element on the left list for each element on the right. Okay. Maybe we just shouldn't be hacky with this. We just shouldn't be hacky with this, should we? So we're going to do map set new, map set difference, map set new. This returns 1, not 0, 2, not 2, not 3, and then 4 through 5. So we're going to be doing this twice. Where are we? Here. We're going to be doing this twice, both for rows and for columns. So empty rows is map set difference, map set new, non-empty rows. Oh no, it's 1 through 0 through height. And I know this doesn't quite work yet, but we'll fix it in a second. Empty calls is going to be 0 through width. Then map set new non-empty calls. And we also need height is length of lines, and width is string.length of list.first of lines. Just copied it from below here. And now height is height, width is width, and empty rows is empty rows, and empty calls is empty calls. Sometimes I really wish we had Rust's nice syntax for eliding the value of a map key if the map key and the value have the same variable name, or if the map key and the variable have the same name. Because repeating every word like this twice is not particularly nice. This works. Map set difference. This is not just the arrange, it has to be map set new. Okay, and we have empty calls and empty rows. Is 2, 5. We have only 3 empty rows, 3, 7, and 10. We have 10? What's a 10? There's no 10. We're going we're off by 1. This has to go to height -1 and width -1. Oh. Damn it. The Vim key bindings are confusing me. And now we have empty rows 3 and 7 and empty calls 2, 5, and 8. Is that correct? Here we go. 2, 5, and 8. Okay, so now we have the empty rows and empty calls. So let's draw them here, because it's nice to draw things. And I'll confess, one of the reasons I'm doing this is so that I can use it as a thumbnail in the YouTube video later. So, I comes from empty rows. I can actually just pass the data here, can't I? This is data. There's no reason to explode the values. Then here we're going to be going through data.galaxies. Here, data.emptyRows. Do. So for each empty row, we're going to draw another one of these rectangles. And we're going to give it a sort of just a very dark gray color. It's not going to have a stroke. The x, which I'm hoping is the first coordinate, is just going to be 0. The width, the y, is going to be I times gal h. The width is going to be the whole width, so 600. And the height is going to be gal h. And this blew up because we don't have data. It's at data. Okay, this drew over... So this drew over a bunch of stars, which is incorrect. Let's do this on the example. See what happens. We're off by 1. We're off by 1. How are we off by 1? 2. So empty rows. The first empty row is 3. This is 0, 1, 2, 3. This is indeed 3. So I don't need that anymore. Here. Why is this drawing it? Oh, 0, 1, 2, 3. This is not drawing correctly. Right? Have I feel like this is rotated somehow. So Okay, so this display is clearly wrong. Why is it wrong? Okay, but this was a horizontal line as I expected, so x and y are the correct things, but I'm doing x and y, this is y, this is x. This is what's wrong. Okay, now it drew it correctly, because we're actually storing the galaxies as I and j, and I is actually the number of the row, so it's the y coordinate. Okay, let's go back to full. Yep, make this even darker. Stylish. Okay, so these are the only rows that will expand. And now we do the same for columns. What's this end here? I don't think this end here is a real thing. Yeah, alright. Okay, now we do the same thing for columns. So this time it's the x, which is going to be j times gal w. And the y is always going to be 0. The width is going to be gal w. And the height is going to be gal h. The height is going to be what? The height is going to be the full height, so it's going to be 600. Okay, so I was right in that we don't have a lot of expansion in the full universe, in the full text input. So the next step here is that we have to do this expansion. I don't know if we're going to be doing that in part 1, part 2. Let's do it in helpers, because this is probably going to be common for part 1 and 2. Def expand. And this takes the input, which is a map that has galaxies in it. And also empty rows and empty calls. And now we have to somehow... Oh, and we're going to have to change the width and height, aren't we? We're going to have to increase height by the number of empty rows and width by the number of empty columns. Okay, so let's not break it up like this. Let's just say expand of data, where data is a map. Okay. So now we have to adjust. Actually, let's just write our full result here. The full result is going to, the return value of this is going to be data, except we're going to change height to be height plus empty rows. Width to be width plus empty calls. Empty rows will be an empty list. Empty calls will be an empty list. Empty list. And then we're also going to need to modify galaxies somehow. So this actually replaces literally everything. galaxies is going to be expanded galaxies. Alright, and expanded galaxies is what? Expanded galaxies... Well, whatever it is, it's going to be a map of the existing galaxies. Because we take the same number, the new galaxies will be the same number of galaxies as the original galaxies. So this is a map operation. Now the question is, what do we adjust I and j by? We adjust I and j by the number of empty rows and empty columns that are less or equal to, no, strictly less than I and j. And we could actually do this with some clever pre-computation, but we don't need to because, look, there's really just not that many of them, so we can just filter, we can always filter over the map sets. We can filter over the list of empty rows and empty columns multiple times, and it's not going to be computationally intensive because it's just 2 of them and then 6 or 5 of them. So, then this returns new I, new j, and ch. I should probably stop storing ch, but we're already committed. So, new I. New I is going to be I plus length of map set. It's not actually helpful to us that this is a map set, is it? So let's turn these into lists. Okay, so it's length of data.empty rows piped into list filter where the argument is less than I. Yes, and then j is going to be the same thing but with empty calls. And less than j. This is it. Undefined variable height. Yeah, this is data, 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 and data. List filter doesn't exist. Indeed, it's a num filter. Okay. Now here we do example. Let's also pipe it into AoC expand. Arithmetic error at line 51. Ah, indeed. This is the length of the empty rows. Here we have the length of data. And this should be our expanded universe. Let's actually, now that we know that it compiles, let's try this on the example. This is the hell. So this is our original input. It just looks weird because all of the squares are so big. But then we pipe this into AoC expand. This should give us this. So this should be equivalent to this. Is it? How can we even tell? Well, we can see that the edges are the same. And indeed, it looks like there's 2 rows here, 2 columns here, 2 columns here, 2 rows here, yep. Then there should be 2 rows towards the end here. Yeah, this is 2 rows. So this looks kind of correct. What happens if we do this on full? well, won't make much of a difference because there weren't that many empty rows and empty columns to begin with. Okay, so now let's actually solve day one. Let's actually solve part one. We now need to compute the Manhattan distance between these two nodes, between every pair of nodes. So the example is 5 and 9. 5 and 9, the distance should be 9. And I claim that this distance is going to be 1, 2, 3, 4, 5 plus 1, 2, 3, 4. Right, so it's 1, 2, 3, 4, 5, and then 1, 2, 3, 4. Yeah, so it's the difference is just the difference in coordinates. It's just the strict Manhattan distance. So here in part one, after expand, we're going to do what are we going to do? We're going to call them to get the galaxies out. And then we're going to compute the distance between every pair of galaxies. We're going to do this with a 4. Yeah, let's say I and j. Let's say I1, J1. And this just goes through galaxies. I really should get rid of the extra character here. That's not helping us. Okay, and then we have I2 and J2, which is also all of the galaxies. Where I2, I1, and J1 is not equal to I2 and J2. We don't want fact where, how do we do this? We want only one half, we want only one pair. We don't want the pairs and also the flipped pairs. So I think the way we do this is I1 is strictly less than I2. Is this sufficient, or do we also need a test on J? We probably need a test on J2. Anyway, so here we have I1, J1, I2, J2, and then we're going to have the distance here, which we haven't computed yet. This is too many things, clearly. So I1, J1 is strictly less than J2. Now hold on, there have to be 36 of them. So let's see what the length of this is. The length of this is 35. J1 less or equal to J2. Surely there's a way to deduplicate this. Okay, I keep getting 35, but I remember them having 36. There are 36 pairs. Am I not seeing? So we have 0, 4, 1, 2, 3, 4, 5, 6, 7, 8. There should be 8 of these. And there should be only 7 of these. 1, 2, 3, 4, 5, 6. So we're missing one here. And this is 8 of these. And then there should be 7 of these, but we only have 6 of these. So 1, 9. 1, 9. What's 1, 9? Let's print the coordinates here. Like, surely that will help. Surely we can add some text in these to yeah. Surely there's maybe MDN has something. Element SVG, okay. How do I do text? The SVG text element draws a graphic element consisting of text. It's possible to apply something something. Okay, so it's just text X and Y. Here, where we draw the rectangle, let's also draw some text to make debugging easier. Text. X is... Actually, let's just do this. What's our text actually going to be? Our text is going to be gal Y, comma, gal X. This should draw something, and it does, but it draws it in a very not nice way. Can we change the center? Presentation. Maybe not. But we can at least change the Y here. What happens if we do plus 20? Okay. Plus gal H divided by 2. Well, this isn't quite right because it should be plus gal H divided by 2 plus 10 or plus 5, which is half of this, the height of this line. Okay. Can we say here height? Can I say 10? What happens if I say 20? Doesn't do anything. Height is probably not an element. But I do have style. Text length. A width that the text should be scaled to fit. Okay, what happens if I say text length 10? 20? Okay, this just sort of squishes it together. It's not quite what we want. Yeah, this doesn't help. But style is a thing. So can I do height 10 pixels? Is this a thing I can do? No, does not look like it. CSS text height. Is this even doing anything? What happens if I do color? This should make the text red. Okay, style is not working. Styling attribute, font size. Absolute size. This is exactly what I need. So font size is 10 pixels. 5 pixels. Font dash size. Alright, this works. And then 10, 20. Yeah, let's go with 20, and then this here should be 10 then. It should be nothing. Okay, so this is clearly... I feel like it's not actually doing 20 pixels. If I look at the computed layout, yeah, this height is 26. It's... Oh, because presumably text size is actually the size without the little comma underneath or something. So this should be plus 13 if I want it to look properly. Plus 6. Good enough. I'm just going to say good enough. Okay, and then here, let's not have a comma anymore. This is going to look terrible in the full example, but good enough. Okay, so now we have coordinates. So back to debugging why 1, 9 is not being matched with one of the other ones. So it's matched with 2, 5, 6, 7, and 2 11s. 1, 9 is being matched with 2, 5, 6, 7, 2 11s, no 10. It's 1, 9 is not being matched with 10. Why not? Okay, so I has to be less or equal to I2, but then either I1 is different from I2 or J1 is different from J2. This should be 36 now. This is 37 now. This is all academic. I could just deduplicate the list. I just want to figure out how it's supposed to be. Okay, so 4, this is fine. Then this one should be 7. 4, 3, 7. Okay, this one should be 6. 6, good. This one should be 5. That's 5 things. This one should be 4 things, okay? This one should be 3 things. This one should be 2 things. This one should be 1 thing. So we're matching 11, 0 with 11, 5 and 11, 5 with 11, 0. 11. Right, so is it like this? Well, if we do it like this, we're not matching something else. What I want here is I1 is less than I2, and then either they're different or I1 is less or equal to J1 is less or equal to J2. This is now showing 45 things. Okay, so 4, 4. Oh, they're matching with themselves. So this here should be strict. Okay, this is good. We now have all the pairs of things we have to compute the distance between. So now let's actually compute the distance. And I claim the distance is going to be simply... let's add one more level of nesting here. And I claim the distance is going to be purely I2 minus I1 plus J2 minus J1. And we know that I2 is greater than I1 and J2 is greater than J1 because of all of the crap above. Right? J2 is always greater than J1. It is not. The thing I tested. So we do apps of this plus apps of this. Now we have some distances. So let's check with their example. So the distance between this one and this one is 8. So distance between this one and this one. So it's 6, 11, 11, 5. We should draw this out, shouldn't we? Yeah, we should draw this out. Let's put this into a function. Def module part1 do. Like, we don't need to put it into, we don't need to draw it out, but I said that today we're doing lots of visualization. So yeah, let's draw it out. Compute distances. This takes galaxies. And then it's going to return data with a new element called distances. And distances is going to be the stuff we computed below. I can delete this and just say compute part1 compute distances. Now we should have the distances in here. We do. All right, let's draw the distances now. So here, we pipe this, let's split it onto multiple lines for readability. Part1 compute distances. It should still run, yep. But now we're also going to display the distances for I1, I2, one more level of nesting, I2, J2, this here was J1. Okay, so I1, J1, I2, J2. Data dot distances do. And here we're going to draw a line. This anymore. Don't need font size. What I want is stroke or line or something. Polygon, line. A line is an SVG basic shape used to create a line connecting 2 points. So we have to give it x1, y1, x2, y2, and then stroke. We're going to split these onto multiple lines, because we're going to have to do some computation. Stroke is going to be red. But not a pure red. Let's do 9 and 3, 3. Okay, so x1. x1 is j1. This is j1 times gal w. y1. This is going to be I1 times gal H. This is J2 times gal W. This is I2 times gal h. We're not using this, and unfortunately we're connecting the corners. Let's connect the centers instead. So in order to connect the centers, we have to add gal w times divided by 2, gal h divided by 2. Is this? Yes. And then here, gal w divided by 2, and gal h divided by 2. And now we're actually going to move this above, and I'm hoping this at the very top. So I'm hoping this will draw the rectangles on top. Yes, right, this is better. Have an empty, unnecessary line there. That's correct. Okay, now we need to draw the distances as well. So for this, we're going to have a text element. It's going to look a lot like this one. Okay, font size 20 pixels, sure. And then x is going to be, there's no gal x, this is, where are we going to put the text? We're going to put the text about at the midpoint of the line. So that's going to be j2 minus j1 divided j2 plus j1 divided by 2 times gal w. Here, this one is going to be I1 plus I2 divided by 2 times some other stuff. And then we're going to display just the dist. And it drew it in black. How do we do text color? Surely we can do text color. Note that the color of the text is set with the fill property. So I guess I do style fill. Here. So style is fill. Okay, that drew. This was not the right text element to modify. This is the right text element to modify. Okay, this is kind of okay. The lines are the digits aren't quite lined up with the number, but maybe we can make that better. Here, I think this is wrong. This should put it directly underneath the line, but it doesn't. Why? Because this is... Oh. Okay, so this is j1 plus gal w divided by 2. This is j1 plus 0.5, and this is j2 plus 0.5, so the whole thing is going to be plus 1. Okay, so now they're close enough. Let's now add the plus 6s. And the color for this is actually going to be 933. Let's make a match. Okay, yeah, this is Good. Yeah. Right. So now let's actually check our computation. So 61215 is 9. Should actually be a slightly different color, shouldn't it? Let's make it a brighter color. Yeah. Yeah. Okay. All right, better. So this should be 9. And it is indeed 9. Now 1 and 7 is 15. So this is 1 and this is 7. So it's the big line that goes from top to bottom. This one to this one. 1 and 7 is 15. This is the 15. I know how to make this slightly better. No, let's say that this is 15. It's probably correct. Now between 3 and 6 is 17. 3 and 6. So 3 and 6 is 17, okay? And then finally between 8 and 9 is 5. What was 8 and 9? 8 and 9 is 5. 5. Alright, so this seems to work. Now we have to compute the sum of the shortest paths. So here we do compute distances, and then we do then. We take distances out. Then we match just on the second. So what's the distances? Distances is a list of tuples. So then we map this, we enum map this. And then we just get the second element of each tuple. Then we compute the sum of this. 374. Okay, and now we try this on the full galaxy. This is a large number. That's the right answer. You are 1 gold star closer to restoring snow operations. Great. But here, this is what happened there was a weird interaction between Wayland, the clipboard, Firefox, and Livebook. Okay, let's see if we can draw the full one, the full galaxy. Oh, it's taking a while to compile, to run, isn't it? Yeah, this might be too big. So we know that compute distance is terminated fairly quickly because that's what we did here. It took how long? It took 0.2 seconds to compute the distance, all of the distances. So then what's going on here is generating the massive SVG. Oh dear. I see my memory slowly increasing. So this finished evaluating. So now Firefox is rendering a gigantic SVG. And yeah, this is... Oof. Well, so this is what the galaxy looks like if you try to draw a full mesh between... This is what the universe looks like if you draw a full mesh of red lines between all of the galaxies. Ugh. Ugh. Yeah, so our visualization is failing us for the whole thing. Let's quickly switch this back to example. And I'm hoping Firefox clears its memory. Yeah, this is much more readable. Alright, let's go to part 2 and see what this is all about. Part 2. The galaxies are much older and thus much further apart than the researcher initially estimated. Now, instead of the expansion you did before, make each row or column 1 million times larger. Aha. That is, each empty row should be replaced with 10 million empty rows, and each empty column should be replaced with 10 million empty columns. In the example above, if each empty column or row were merely 10 times larger, the sum of the shortest path between every pair of galaxies would be 1030. If each empty row or column were merely 100 times larger, the sum of the shortest path between every pair of galaxies would be 8410. However, your universe will need to expand far beyond these values. Starting with the same initial image, expand the universe according to these new rules. Then find the length of the shortest path between every pair of galaxy. What is the sum of these lengths? Okay, so this is a gotcha in case, instead of doing what we did where we store the coordinates and then we just do arithmetic on the coordinates, if you instead try to generate the much larger grid. Okay, we can do this. So part 2 is going to be a lot like part 1. Let's create a new section here. Let's call it part 2. Part 2. Then we branch this off of... Okay, so we're going to branch this off of helpers so that we don't have to recompute part 1 every time. And then we're going to move compute distances into helpers. Here, instead of part 1 compute distances, we have helpers compute distances. This should still work. Helpers compute distances. What did I do wrong here? Oh, this is AoC, not helpers. Yep, and that's 923,514. 923,514. Okay, so now in part 2, we're going to start in a very similar way. We're going to do AoC read input example. Then we're going to do AoC expand. However, this time we're going to pass a factor argument. Yeah, let's call this a factor. And then the rest of it is actually going to be the same. And since their examples are doing this, yeah, right now here, we're going to do an optional argument in Elixir, an optional named argument in Elixir. So the way you do this is you have a second argument, you call it opts, and it defaults to an empty list. Then you take out the argument by saying keyword get opts factor and some default value. In our case, the default value is 1 because the expansion factor is 1. Then here, where do we... Right. So this is where we actually expand the universe. Now we're going to expand it by factor times that. And factor times this. So now part 1 should be unchanged, and it is indeed unchanged, and part 2, the result is 374. Yep. Now we're going to try these ones. So what happens if we give it a factor of 10? We get 1112. Oh, interesting. Now, instead of the expansion you did before, make each empty row or column 1 million times larger. That is, each empty row should be replaced by 1 million empty rows. I was really expecting this to just give out the correct answer. Out of curiosity, if I do 9... Ah, we're off by 1. We are off by 1. So this isn't quite right. So it is right for 1, right? If we do factor 1, it's 374. And then if we do factor 10, it's off by 1. Is it off by 1 at 100 as well? It is off by 1 at 100 as well. Oh, because we already have a row, don't we? No, that doesn't make sense. So, why is this wrong? Like, clearly it seems to be saying that factor of 1. What's different between 1 and 2? Because there should be a difference between an expansion factor of 1 and an expansion factor of 2. Right. Because our original expansion factor is 2, because each row is expanded into 2 rows. Yes, each row is expanded into 2 rows. So here, that should be a default value of 2, and this should be minus 1. And part 1 is unchanged. Now part 2. If I do 10, now it gives the correct answer. 100, now it gives the correct answer. Do we have a third example? We do not. We should just now try 1,000,000 and see what happens. This should not take any longer to compute, because it's just the same arithmetic and computers don't care about how big the numbers are. And in particular, Erlang and Elixir don't care about how big integers are, because they always use big num arithmetic. So this should be the answer. That's not the right answer. Your answer is too low. Because I'm doing this on the example. I need to do this. Reloaded this to get rid of the weird interaction, the weird clipboard interaction. Okay, I don't need to run this on the example, of course. I need to run this on full. So this is the right answer. Okay, I have to wait for 30 seconds before trying to submit this. I guess that's the punishment for entering the wrong answer. Now, can we still display this? The display here should work. It's not part 1 compute distances. The display should work, although we do the expansion. Out of curiosity, what happens if we try to do a factor 10 expansion here? It should mostly still display. But we're not computing. Where is it? The new width and height aren't computed correctly during the expansion. Yes, here we need to do factor -1 times this, and factor -1 times this. Except it's not factor -1, is it? It's just factor. Yes. Okay, and this is the greatly expanded universe. Although the font sizes are wrong. First, let's see. We should be able to submit our answer now. That's the right answer. You are 1 gold star closer to restoring snow operations. You have completed day 11. Okay. So we're done with part 2 as well. And we only got a wrong answer because I wasn't careful and I submitted the answer for example instead of for full. So now let's just make this particular image a bit prettier so that I can use it as a thumbnail later. The big problem here is that the font sizes are way too big. So, font size is going to be 20 at 20 for height 10 was about good. So it's going to be 20 times 20 divided by data dot width divided by 10. So this should make our font And we also need to say here, font size 20 pixels. Let's just make this into a string that says 20 pixels. Let's pass it as an argument. Let's now split this over multiple lines. No, 2 lines is sufficient, actually. And then, where's font size? Here's font size. Now this takes the parameter value. We have another text somewhere in here. Here we go. And this actually needs to be in an EX value block. Syntax error before. Where did I do this? There's one font size and syntax error before this on line 66. Line 66 is the call to the EX evaluation. But one of these is wrong. Why is it wrong? This is the same way. Oh, it's not equals, it's percent. Again, if this was Emacs, I'd have macros, but this is not Emacs. Okay, and now we have the expanded universe and much smaller text, except that the offsets are completely wrong, which is unsurprising. So here, instead of 6, it's going to be font size divided by 4, because that seemed to be about right. Here is going to be font size divided by 4. 5 pixels. Yes, that is indeed not number. Okay, so this one here, it's pixels. Here is pixels again. It should compile. Yep, and it's a bit more centered, which is nice. This one should also probably font size divided by 4. Okay, and this looks kind of okay. Let's make, I said at the start that we'll make the squares circles, we'll use ellipses or something. Although circle exists, because this looks more like a galaxy. CX, CY, and R. Okay, so where's the rectangle here? This is going to be circle. Stroke is probably fine. Now this is going to be CX, CY, and then, was it R? R. So R is the easy one. We're just going to use gal W divided by 2. Sorry. And then CX is this plus gal. We have to add a 0.5 here since we're writing since we're describing the center of a circle. No, we didn't draw it at all. Why not? CX, CY, and R, the radius of a circle. Is there an example? There's no example. Number absolute length. Two properties. Do I need to say pixels? I didn't have to say pixels on the other ones. SVG circle example. Here we go. CY, CX. Okay, we don't have to say pixels. What do I say? Fill. Global attributes. Fill. Yep. Is there a stroke as well? There is a stroke. This should work. Why does this not work? It's not called circle? I blind. It's called circle and then CX, CY. Circle, CX, CY, and R. It's just not displaying it. Oh, but I can inspect this, can't I? And see what it actually generated. Yep. This is the big rect, and then there's a lot of lines. And then somewhere in here, there's going to be a circle. Here is a circle, and we're doing fill, stroke, CX, CY, and R is an empty string. Why is R an empty string in our circle? Because I forgot to put an equal sign here. Okay? Now, kind of looks like crap, so let's make this way lighter. Bit better, maybe? Red, green, blue. Let's make it blue tinted. Okay, it's blue tinted. And I see the stroke isn't adding much. The text here should be maybe divided by 3 instead of 4. Yeah, that looks more centered. Maybe for x it should be divided by 2 instead. 2.5. Okay. This looks kind of alright. What happens here if I go back to factor 1? If I do factor 2. I'm going to expand this a few times and see which... so the goal here is to get a nice thumbnail. So I want one that doesn't... Yeah, this looks kind of okay, because it's both readable and also... Yeah, this works, except the texts are still misaligned. How do I line text? Text. The SVG element text. Surely I can align... I can align the center or something. And do font family monospace. Let's start with that. This text here. Font family monospace. Okay, now it's more predictable. Now it looks kind of okay, in fact. Yes, let's leave it at this. Is there anything else we can refactor here. The helpers module is fine. There's nothing bad in it. Like, we can definitely code all of this and not pass so much data around, but passing all of this data is helpful when we draw it out later. Part 1 and Part 2 are basically identical, except for the factor. Yeah, so let's put this all into a function called SumDistances. We have some distances, and it takes data as an input and some options. And then... oh, in fact, it doesn't take data, it takes Kino input as an input. And then it passes the options unchanged to expand. Right, this hasn't broken, so instead of AoC read input, we now do some distances, a full, and no extra arguments. Oh, and this will blow up because we did not specify a default value for the options here. Yes. But now this should give the same result, and it does. And here we do the same thing. Some distances, except we also have a factor of 1,000,000. And this should also not change the result, and it did not. Delete the extra line here. Our visualization also works. Yep, and it was erroring out because we had changed the module above and had not reevaluated the cell. So that's it. Yeah. What does the leaderboard look like? Today was pretty easy. Yeah, today was pretty easy. We complicated a bit by writing this visualization, but I don't regret it. This was very educational. Anyway, so back to stats. Yeah, more people have solved this today than yesterday. This number was around 13,000 yesterday at around this time. Of course, it's also Monday, so most people are probably working. Well, on the upside, lots of people actually managed to finish yesterday, which is nice to see. Okay. Yeah. And basically everybody who solves part 1 also solves part 2, because presumably very few people actually did try to do the expansion graphically using strings. Right. Then that's it for today. Thank you for watching, and see y'all tomorrow.